So previously we talked about finding antiderivatives or indefinite integrals of functions, and I'm going to talk about how you could find the exact antiderivative function given some set of initial conditions. So for example, suppose I want to find my f of x derivative function is given by 12x cubed plus the sine of 2x. So this is a pretty complicated function, and this is the initial condition. The idea here is that if I know what the derivative is, I need to be able to take the antiderivative of this to get back to the original function. So that's the first step. I'm going to take the antiderivative of 12x cubed plus the sine of 2x dx. And when I take this antiderivative, remember by antiderivative rules, I can break this sum up into two antiderivatives, the integral of 12x cubed plus the integral of the sine of 2x. Oops, and there should be a little dx as I split them up into two pieces. They're still being taken with respect to x, that's the variable. And by power rule, I'm going to do this quickly. I'm going to say that because it's an integral, I need to raise it up to the fourth power. So this one ends up being x to the fourth, and then I have to divide by 4. Similarly, I'm doing the same thing in my head. The integral of sine is negative cosine, so I end up with the negative cosine of 2x. But for the same reason, because if I take the derivative of this, I would have to apply chain rule and multiply it by 2. So I'm going to take this, oh, maybe this looks messy, negative cosine of 2x and multiply it by 1/2, because the derivative will be sine of 2x. But we have to worry about the fact that we add plus c. The idea of initial conditions is that I use this final extra piece of information to find out what this c must be. Let's simplify this a little bit. 12 over 4 is 3x to the fourth minus 1/2 of the cosine of 2x plus c. Now how does this information help us find going to be? This is telling me, oops, this should be a capital F. Sorry, all of these should have been capitals. If I plug 0 into this function, this is now my, because I found the antiderivative of the derivative function. If I plug in 0, I should get out 8. So this is telling me that f of 0 is equal to 3 times 0 to the fourth minus 1/2 of the cosine of 2 times 0, which is 0, plus c should be equal to 8. And when I plug all of this in, 3 times 0 is 0, minus 1/2 the cosine of 0 is 1, is equal to 8. Oh, plus c. So now I have to add 1/2 to each side, and I find out that c is equal to 8.5. So notice that c isn't exactly equal to just what this initial condition is, that I have to plug in 0 into my function to find out what c value I would need here so that when x equals 0, my output would be equal to 8. But this gives me my final answer for the antiderivative of this function right here when evaluated at f equals 0 being equal to 8. So my final answer is that f of x is equal to 3x to the fourth minus 1/2 times the cosine of 2x plus 8.5. It's exactly the antiderivative that I found here, but I solved for c.